On August 3, 2015, in the quiet Dutch town of Alphen aan den Rijn, two massive lifters stood ready beside the River Rhine, prepared to lift a piece of history. Not a single soul suspected that within seconds, those same machines would turn into a falling disaster. These were massive mobile lifters, the kind normally used to hoist entire building sections into place. Each one could pick up hundreds of tons, towering high above the river and streets of Alphen aan den Rijn. Built with Dutch engineering and trusted across Europe, they were designed to lift heavy loads with incredible precision, stable, reliable, powerful. So everyone expected this job to be routine. But if everything was so strong and high-tech, then how did such a well-planned construction project go so terribly wrong? Before we dive into the chaos that followed, let's take a quick look at how a lift like this normally works. The machines must be positioned on solid ground or a stable surface. Every move is measured carefully, the arm length, the angle, and the exact weight of the cargo. Engineers calculate wind forces, tidal movement, and motion from the load itself. Everything is double-checked because one small imbalance can start a chain reaction that no one can stop. But this time, things were different, and not in a good way. Instead of standing on firm land, both machines were placed on floating barges in the canal beneath the Juliana Bridge. The plan looked simple from above. Pick up a huge steel ramp, basically a bridge section, and slowly swing it into place. A synchronized dance between two giants. On paper, the operation seemed brilliant. A perfectly calculated lift involving 110 tons of steel, pontoons designed to balance the weight, and a town excited to see a new bridge take shape. The system looked confident, stable, and ready. Unfortunately, the real world does not always respect flawless plans. As the steel ramp began its slow ascent, the pontoons supporting it started reacting to the shifting weight. Floating supports behave differently from solid ground. Even a tiny imbalance can turn into movement. That initial movement became a noticeable sway. A few centimeters off-center may appear minor to an untrained observer, yet for engineers and crane operators, it signaled the beginning of something dangerous. The tilt grew more pronounced. One of the lifters, towering like a vertical steel backbone of the bridge, leaned farther than its design allowed. The heavy arm attached to it no longer kept its straight, rigid posture. It began to bend under the rapidly increasing and uneven load. Crew members shouted warnings while others rushed to their safety stations, the clatter of their boots echoing off the metal deck. Radios erupted with urgent instructions as tension spread faster than the equipment could respond. Then a sound tore through the air that every construction worker fears. A long creak of metal pushed beyond its design tolerance. It was the structural equivalent of a final warning. Unfortunately, it came too late. The first lifter gave way. The massive support structure did not fall harmlessly into the water, as many would assume. Instead, the heavy bridge section, still chained to it, dragged the collapsing machine sideways. Because the cables had not yet been released, the entire assembly acted like a deadly pendulum. The second lifter, still holding its part of the load, was violently yanked off balance within a heartbeat. There was no chance to correct the motion or stabilize the machinery. Physics simply took over. Within seconds, two towering machines toppled together. They did not merely drop. They crashed into the nearby street with catastrophic force, flattening a line of small businesses and homes that stood only meters away. These buildings had stood for years through storms and floods, yet they could not withstand the crushing weight of collapsing steel. A massive cloud of dust exploded outward, consuming everything in its path and turning the narrow riverside road into a scene of chaos and disbelief. Here's a question that still makes experts shake their heads. How could multiple teams of professionals overlook such an obvious risk? Barges are not on solid ground. They move. They tilt. A lift that requires perfect stability was made unstable from the start. Add the huge weight of the bridge section, and it was only a matter of time. Turns out the mistake didn't happen in those final seconds. It happened much earlier, during the planning stages. The Dutch Safety Board later revealed that risk calculations were incomplete. The flexibility of the arms wasn't properly accounted for. The pontoons didn't have enough stability. Safety margins were tiny. Wind, tide, and motion weren't given the respect they deserved. So who was responsible? The answer isn't just one person: contractors, engineers, supervisors. Everyone connected to the lift shared a piece of the blame. There wasn't enough communication. There wasn't enough caution. Everyone assumed the plan would hold because, well, it always had before. But construction doesn't care about confidence. Physics always wins. And while the immediate reaction was fear of mass casualties, a miracle happened in the middle of chaos. No one died. People were injured, some 20 hurt in different ways, but not a single life was lost. For a collapse this size, that statistic still feels unreal. Families sprinted out of homes seconds before everything came crashing down. Workers leapt from the barge into the canal. Others were just lucky they took one step left instead of one step right. Still, that doesn't erase what was damaged. Shops reduced to flattened piles. Homes split open like cardboard boxes. Memories, belongings, and livelihoods buried under steel arms and shattered brick. The emotional cost, impossible to measure. The financial cost, estimated in the tens of millions. Insurance companies in the city spent years trying to rebuild what vanished in a single moment. There were also the psychological scars. Alphen is a peaceful place, safe, quiet, the kind of town where people know their neighbors. After the collapse, many locals couldn't walk near the site without feeling their hearts race. What once felt normal now looked frightening. But from that fear, something important was born. The incident triggered a serious wake-up call across the Netherlands and beyond. Construction companies reviewed their procedures. Regulators tightened requirements for lifts done from floating platforms. Training programs added new safety lessons. Risk management became stricter, more realistic, and less trusting of, "it should be fine." A criminal investigation was opened to understand exactly how so many warning signs were ignored. Engineers asked themselves a vital question. If this could happen in a well-organized country like the Netherlands, what about places with fewer regulations? Suddenly, the world was paying attention. It wasn't just about machines failing. It was about humans assuming that nothing would go wrong and being terribly mistaken. And that's where the real lesson lies. Technology might be powerful. Calculations might look perfect. A plan might seem safe. But safety isn't about assumptions. It's about preparing for the worst, even when you're sure the worst won't come. Because sometimes all it takes is one unexpected shift, one overlooked detail, one gust of wind, and everything can fall apart. There's also a second lesson, maybe just as important. When disaster struck, rescue teams didn't hesitate. They rushed in fast using heavy machinery and trained search units normally sent to earthquake zones. Their work saved lives that could have easily been lost. It's easy to talk about mechanical failure, but we can't forget the human response. Brave, immediate, life-saving. In the end, the town was rebuilt. The broken street became whole again. People went on with their lives, but Alphen aan den Rijn will never forget how an ordinary day turned into one of the most shocking construction accidents in Dutch history. So what do we take away from all this? Plan better, communicate better, respect physics. And never ever underestimate the power of small mistakes when dealing with massive machines. If two giants on barges can fall, then anything can, unless we learn and do better. And here's a question for you as we wrap up. When you see something huge and complex being built, like a bridge or a skyscraper, do you feel more admiration for the achievement or more fear of what could go wrong? The truth may be somewhere in between.